current I in terms of drift speed is given by NAE into Vd. Of course, it is magnitude. Now, N means free electron density, it is the number of free electrons per unit volume. A, area of cross section of the conductor, is the elementary charge. Now, we know drift speed is given by the formula, it is E by m into tau. So, drift speed is equal to, it is E tau by m. What is E here? Electric field. Tau is the relaxation time, and E is given by V by L. Therefore, drift speed is equal to, it is E, instead of capital E we write V by L. So, mL into tau. This is the formula for drift speed in terms of potential difference and relaxation time. Substitute this value in this equation. So, I is equal to NAE into EV by mL into tau. I is equal to, simplify this one, I is equal to, it is N A E into E square, you bring a tau inside, tau divided by mL bracket into V, where V is the potential difference. Now, look at the terms inside the bracket. At the given temperature, very important, all the terms inside the bracket are constant. Look here, free electron density is a constant, area of cross section of the wire or conductor is a constant, charge on the electron constant, at the given temperature tau is a constant, mass of electron, length of the conductor, these two are also constants. Therefore, all these are constants. Therefore, we can write I proportional to V. I proportional to V. What is this I proportional to V? Is it not Ohm's law? It is nothing but Ohm's law. Current through the conductor is directly proportional to potential difference across the ends of the conductor, provided temperature and other physical conditions are kept constant. So, we study about Ohm's law separately. The next discussion is on Ohm's law only. But this is the way, or this is the method to deduce Ohm's law, current through the conductor proportional to potential difference. Now, we can rearrange this formula again. We can write the equation for V by simplifying this one. So, V is equal to, if you cross multiply, it is mL divided by N A E square tau into I. Again, all these terms are constant. If it is constant here, what about here? In this formula also it is constant, we can write it as Ri. It is mathematical form of Ohm's law. So, you know, even in high school level you studied this one. Ohm's law, mathematically we write it as V equal to IR or Ri, both are same, where R equal to mL divided by N A E square tau is known as electric resistance of the conductor. Known as what? Electric resistance of the conductor. Now, this part is actually not in the NCERT book. In the NCERT book only this derivation is there. But if you continue a little bit, we end up with the Ohm's law, and it is easy to understand the statement of Ohm's law. And moreover, this relation is very useful for competitive exam. Resistance in terms of dimensions of the conductor. So, very useful to solve number of problems in entrance exam, CET, etc. So, remember this equation. Now, I want to explain Ohm's law. What is Ohm's law? See that it is a conductor, uniform conductor, it is at higher potential, it is at lower potential, it is by connecting it to the cell or battery. V is the potential difference and I is the current. Now, Ohm's law states that current through the conductor is directly proportional to potential difference applied across the ends of the conductor, provided temperature and other physical conditions are kept constant. So, mathematically we can write like this: current through the conductor is directly proportional to potential difference across the ends of the conductor, provided temperature and other physical conditions are kept constant. Now, I proportional to V, or to make it simple, even we can say V proportional to I, means it is a simple logic. If you have got a large current, means potential difference, think that it is higher, like that, or V is equal to R I. What is R? R is the proportionality constant known as electric resistance, or simply known as resistance of the conductor. So, state and explain Ohm's law, you can expect for 2 marks. It is a standard question. State and statement carries 1 mark, explanation carries 1 more mark. And while writing statement, be careful. You have to write full statement, like current through the conductor is directly proportional to potential difference across the ends of the conductor, provided temperature and other physical conditions are kept constant, and this is explanation. You write these 2 steps, explanation part. Now, what is the meaning of physical conditions? Physical conditions are here, it represents dimensions of the conductor, like length and area of cross section. Physical condition means length and area of cross section. Okay. Now, from this I want to define resistance of the conductor. So, what is the formula for R, or equation for R? R equal to V by I. So, how to define electric resistance of a conductor? Electric resistance of a conductor is defined as ratio of potential difference across the ends of the conductor to the current through it. Very simple. And resistance is always expressed in terms of ohms. That is a very famous term or famous quantity in physics. Electric resistance expressed in terms of ohms. Now, if V equal to 1 volt and I equal to 1 ampere, then substitute here R equal to 1 volt by 1 ampere, that is taken as 1 ohm. It is the symbol of ohm. This is symbol of ohm. So, how to define resistance of a conductor as 1 ohm? Resistance of a conductor is said to be 1 ohm if 1 volt of PD applied across the ends of the conductor produces the current of 1 ampere in it. Means, just see here, if this PD is 1 volt and how much current it has to produce? 1 ampere. potential difference is 1 volt, current through the wire is 1 ampere, then its resistance is 1 ohm. So, this is the definition of 1 ohm you can expect for 1 mark in annual exam. Even you can expect this, define resistance of a conductor for 1 ohm, define 1 ohm resistance of a conductor, that also you can expect. Now, what are the drawbacks or limitations of Ohm's law? Ohm's law is not a general law because it has got so many drawbacks. The drawbacks are there in the statement itself. We will get 2 points from the statement. First, Ohm's law is applicable only when temperature is kept constant. If temperature changes means Ohm's law is not applicable, and physical conditions are kept constant means length and area of cross section must be constant. Let us say you are stretching the wire. If you stretch the wire, at that time Ohm's law is not applicable. Or you hammer the wire, you take a wire and hammer it, then area of cross section changes, Ohm's law is not applicable. So, you will get 2 limitations from Ohm's law itself. Okay. What are the other limitations of Ohm's law? Because in exam you can expect even for 3 marks, and it is a very important question. Mention the limitations of Ohm's law. So, what are the other limitations of Ohm's law? Ohm's law is applicable only for metals, remember. It is not applicable for electrolytic solutions. For example, if you pass the current through salt solution, common salt solution or copper sulfate solution or impure water, definitely current flows, but that solution does not obey Ohm's law. Therefore, electrolytic solutions they do not obey Ohm's law. That is one more limitation. Ohm's law is not applicable for the semiconducting devices like transistor, diodes or any other integrated circuits that they are made up of semiconducting material. They do not obey Ohm's law. Ohm's law is not applicable to the vacuum tubes or discharge tubes because they contain, like discharge tube, it contains gas at very low pressure, it is not a metal, therefore, it is not obeying Ohm's law. So, these are all the limitations of Ohm's law. And even for metals, Ohm's law is not applicable at very low temperature or extremely high temperature. What is the meaning of this? If you take metal like copper wire does not obey Ohm's law at extremely low temperature or extremely high temperature. The other important limitations of Ohm's law are like this. Ohm's law is it is not applicable for metals when current is extremely high. The reason is when large current flows through the conductor, it produces more heat, thereby temperature increases, and when temperature increases, Ohm's law is not applicable. If you plot the graph of voltage versus current, then as the voltage changes, current also changes, therefore, we expect straight line, graph must be a straight line. But experimentally the graph is not a straight line. As the voltage increases, current increases, which produces more heating effect. Therefore, graph becomes curve. So, like this. What we expect is a straight line, but instead of straight line, graph becomes a straight curve. Therefore, whenever graph of I versus V is a curve, we can say it is not obeying Ohm's law. If you take semiconductors, best example is diode or transistor, they are all made up of semiconducting materials. If you plot the graph of V versus I, the graph is like this. It is a curve, non-linear. Therefore, it is not obeying Ohm's law. And if you take some other type of semiconducting materials, the graph of V versus I is like this. It may be like this. It is a very typical graph. So, it is not a straight line, means it is not obeying Ohm's law. And what is more interesting point is here. If you take any particular current here, for that particular current there are two corresponding voltages, means relation between I and V is not unique. Here it is unique, one particular current, one particular voltage. Here also it is almost unique, but here for one current there are two voltages. Again, this type of if you get a graph of this type, means it is very clear that material is not obeying Ohm's law. Now, see here in this graph, if current is very small, then graph is a straight line, means when current is very small, the quantity of heat produced in the material is less. There is a rise of temperature, but the rise of temperature is negligible, therefore, graph is a linear. But when current is very high, graph deviates from straight line nature, it becomes a curve. So, therefore, even for metals, when current is very high, it is not obeying Ohm's law. Now, how to remember this equation? V equal to IR. It is a very important equation to solve the problems or for the further study in this topic. And some students are writing wrong equation in exam hall, means they write like this, I equal to VR. Is it not a wrong equation? It is a wrong equation. Or some students are writing R equal to VI in exam hall. It is also wrong. What they think? All the three terms are there and equation is correct. So, it is confusing for some of the students. Instead of writing correct formula, they write different equations. All of them are wrong. So, there is one easy way to remember this. There is one easy method to memorize this. So, what is that? You say like this, very important relation. Ohm's law can be remembered like this, very important relation. Look here, very V, important I, relation R, and where is the equal sign? Immediately after first value or unknown. So, V equal to IR. It is the mathematical form of Ohm's law. So, remember this one. Even in exam hall you can write without any confusion, V equal to IR, very important relation. Now, next one I want to explain about free electron mobility. Free electron mobility. What is free electron mobility? It tells about movement of the electrons inside the conductor, means are they move easily or whether they move with some difficulties. Now, you may ask, resistance is there no to explain, higher the resistance more difficulty, then why this is required? Yes, resistance is what? It is the macro value, bulk value, microscopically free electron mobility. So, what is the meaning of free electron mobility? Free electron mobility is the easiness with which electrons are moving inside the conductor. How to calculate? Free electron mobility, its symbol is mu, and it is always calculated as magnitude of drift velocity to the magnitude of electric field. So, this is the drift speed divided by magnitude of electric field. This ratio is known as free electron mobility. If this ratio is high, electrons are moving easily. If this value becomes less, we come to know that electrons are moving, but there is some difficulty, means resistance of that conductor is higher, like that. So, it is how to define it? Very simple. Free electron mobility can be defined as the ratio of magnitude of drift velocity to the magnitude of electric field. Now, if E equal to 1, then mu is equal to mod of Vd. Therefore, this is one more definition. Free electron mobility can be defined as drift speed acquired per unit electric field. Drift speed acquired by the free electrons per unit electric field. So, this is the another definition. You can expect for 1 or 2 marks, and it is very clear from this equation, both of them are magnitudes, therefore, it is a scalar quantity. Free electron mobility is a scalar quantity. What about SI unit of mu? SI unit of mu is this is the speed meter per second, and it is electric field. Electric field is Newton per Coulomb. If you simplify this one, it is meter divided by second into Coulomb per Newton. But we know Coulomb divided by second, charge, Coulomb means a charge, second means a time, charge by time, is it not current? What is the SI unit of current? Ampere. Therefore, it is meter Coulomb divided by second, ampere divided by Newton. And be careful, do not read this one as a milliampere. No, it is meter ampere divided by Newton. So, it is better to write like this, ampere meter divided by Newton. I think there is no chance for confusion. Ampere meter divided by Newton. This is the SI unit. And one more unit is there. What is the one more unit? See, electric field has got one more unit, volt per meter. Instead of Newton per Coulomb, we can take it as volt per meter. Therefore, mu has got the unit, this is meter per second as it is, divided by electric field volt per meter, volt per meter, meter into meter, meter square divided by, this is volt second, this is another unit. Therefore, free electron mobility has got two units. One is ampere meter divided by Newton, and one more is meter square divided by volt second, and it is which quantity? Scalar quantity. Now, free electron mobility mu, or even you can write mu E, no problem. Free electron mobility is equal to, it is a drift speed divided by mod E. Now, we know I current is equal to NAE into Vd, or what is Vd? This is the drift speed is equal to I divided by NAE. So, we substitute that one here. Therefore, free electron mobility is equal to, it is I divided by NAE into E. This is one more equation. One more equation for free electron mobility in terms of electric current.